The tutorial today will focus on two-dimensional equilibrium rigid body problems. So as usual, we will focus on questions from past examinations, whether midterm or final exam, specifically on 2D equilibrium rigid body problem. Right. So Bismillah, Assalamualaikum warahmatullahi wabarakatuh, and inshallah, hopefully you are ready for today's tutorial. Now, we have covered in the previous tutorial specifically on the free body diagram with regard to rigid body equilibrium, right? So hopefully you have covered those things and you have fully understand how to draw the free body diagram, because for today and the next tutorial session, we'll focus straight away on how to solve the problem, the equilibrium problem, without discussing too much on the free body diagram. So hopefully you have understood first how we actually establish the free body diagram. Remember, the very first step, always the very first step for solving equilibrium problem is to draw the free body diagram first, right? So make sure you understand that, you understand how to draw the forces, the reaction forces from different type of supports, and then establish free body diagram, and then we can go to this part here where we will solve using equation of equilibrium, right? So in today's session, we will not have that many questions actually, because we will focus on two-dimensional problem, 2D problem, and from the past exams, apparently most of the question will test you on a 3D problem, equilibrium problem, right? So the trend is as such. However, for the 3D problem, we will cover in the next tutorial, inshallah. So today we will only focus on 2D problem. So there are only several questions, but still it is possible that it is going to be tested on your examination. So you still have to understand how to address 2D problem, right? And normally if you have problem to understand 2D, it indicates that you will have more problem in 3D. Generally speaking, it tend to be like that, right? So without further ado, let's go. And before that, if you need the PDF for the questions that we will be covering in this tutorial, download the PDF in the description box below. And do attempt, do test your mind whether you can actually plan and execute the steps. And without further ado, let's go and to solve the first question for today. So in this question, as you can see, it is quite a short question. You have the diagram there. It's a beam, horizontal beam, with a distributed loading there. And then the question says, determine the reaction at the support A and B for equilibrium of the beam shown in the figure. Right. So this question actually tests chapter 5 combined with the distributed loading in chapter 4, right? So we have covered also previously in the one of the previous tutorial how to deal with the distributed loading. So it is expected that you already know how to deal with that, right? So based on the diagram there, so again in equilibrium problem, so hopefully, because we are now covering the chapter of equilibrium, so you will know by default you have to draw the free body diagram first, right? However, in the exam, the question will just be given in a certain instruction, and then you have to know on your own whether this is an equilibrium problem or not, right? For example, in the previous chapter, sometimes the question asks, what is the resultant force? What is the resultant moment? What is the moment of this force about a certain point? Those are not equilibrium problem, right? That's just to calculate a certain force, calculate a certain moment, right? So no free body diagram required. However, whenever you will use summation of forces equal to 0, hence equilibrium problem, free body diagram is a must. Otherwise, we do not know whether your plus or minus in your summation of forces or summation of moment is correct or not, because that must be based on a certain free body diagram. All right. So going back to this question here, first step, as usual, draw the free body diagram. So we will just have the beam, and then at A you have pin support, so you have AX and AY. Obviously both of these are assumption in the sense that the direction can be to the right or to the left. upwards or downwards. So you have to assume something and then move on, and then after the calculation you will know whether it is actually a correct assumption or it's the opposite way, right? Not a problem. And then you have a normal force at B. This is not an assumption, right? So by now you should already understand this must go upwards because the restriction of the roller is preventing only downwards, right? It will not prevent movement upwards, hence the normal force is always upwards. And then you have that distributed loading, so from there you will have two forces here. One is from the rectangular, so basically that is 100 Newton per meter time distance of 4 plus 3 is 7 meter. We have done this in the previous tutorial, right? So this is 700 Newton, and then there's the triangle there, so half times 100 Newton per meter times 3 meter, so you'll get 150 Newton, right? And the distance, so let's draw the distance. I'm using the red color here, so this one is at the middle, so it should be 3.5 meter. This one, because that 3 meter divided by 3, so you have 6 meter here, and then you have 7 meter here. Hopefully the drawing is clear in the video. Alright, so this is the free body diagram. All the forces, the known must be shown the value, so you have the value. The unknown must have a label properly, label, and the distance, the dimension have to be shown, especially the dimension required for subsequent calculation, right? So you will know that this will you will need to calculate moments, so the distance must be clear, right? And it is not a must to draw the distance in such a way. You can just say this is 1 meter, etc. However, from my personal experience on myself, I tend to make mistake forgetting to add the dimension, etc. if I do not do this one. So for anyone who have the same tendency as me, I personally do advise that you always show the distance from one side from the beginning, so that when you want to calculate moment later on, it's quite clear. This distance, this distance, this distance, right? When you have force times distance. Okay, so from here, again the question says determine the reaction of the support at the support A and B, meaning that the final answer should give what is AX, AY, and B, right? How to do that? So we have 3 unknown, and we have of course 3 equation in 2D: summation of force X, summation of Fx, summation of Fy, and summation of moment, right? So the easiest way always is to start with moment, because it can cancel 2 forces, right? For instance, in this case, summation of moment about point A is 0, about this one, point A. Hence, we will only have 1 unknown, and we can straightway solve, right? So let's take counterclockwise as positive. So in this case, this is counterclockwise, so NB times the distance of 7, and then this one is clockwise, so minus. So we'll start with this one, 700. The distance is 3.5, and then this one again minus because it's clockwise. So 150, a distance of 6. All of this should equal to 0, right? This is the original equation of equilibrium, one of the equation of equilibrium. This is expressing this one, right? Now, just to add here, in terms of the exam, you cannot skip steps like this, right? Even though it is obvious and you can do this in your mind and straightway go next, right? But depending on your institution, right? But for my students, I do allocate the mark for each steps, right? So if you skip steps, you do not indicate and show clearly that you understand this is where it's coming from, etc., you will lose the mark there, right? So do not skip steps, especially important steps like this, right? Because this is the summation of force, this is equal to 0. Alright, so from here you can calculate what is NB. So if you calculate this one, you should get, what is that, 478.57. Newton, right? Do verify the number. All right, so after you get that one, then you can do summation of, let's say, okay, do we have enough space? Okay, let's do summation of Fy equal to 0 if you take upwards as positive. So I will have a y positive and then minus 700 minus 150 plus 478.57 equal to 0. If you calculate this one, ay equal to 371.43 Newton. That's 2 already. And then this one is actually quite simple in this case, because you will notice that, oh, there's no other x component forces, right? So do we have enough space? So I'll use this space here. Summation of fx equal to 0 if I take positive to the right. So you'll notice that straight away ax equal to 0. So this question is actually quite short, because there you go, only several minutes, all is settled, right? So normally that's perhaps one of the reasons why 2D question is not being asked in the final exam, especially that much, because it is quite short. Normally for 3D it will be quite longer, because you will deal with a lot more equations, right? 6 equations to be exact. All right, so that's the question number 1, right? So again, here it is combined with the distributed loading. So if you already make a mistake in the distributed loading, it will affect the answer, right? So make sure you understand every single chapter that we have covered. All right, so moving on to the next question. Okay, this is the second question. So you have the diagram there. It is quite similar to the question that we have just covered just now. You have two parts here, A and B. Part A, determine the reaction at the support A and B for equilibrium of the beam. Part B, if the support at B is replaced by a pin support, can the reaction at support A and B be determined? Why? Alright, so if you look at this, it's straight away similar to the first question that we have just covered. So I do not need to explain that much. We'll just straight away to do the calculation. Of course, we will discuss a bit on part B there if something need to be discussed, right? So straight away, again, you should know the drill by now. Free body diagram. So you have the beam in this case, yet again, and then you have pin at A. So you have AX, oops, AY. You have roller here, so you have NB. And then from rectangle, if you divide the distributed loading to two shapes, so you have the rectangle and the triangle, right? So for the rectangle is basically 200 Newton over meter times the distance of 5 and 3, which is 8 meters. So you'll get 1600 Newton. Is it in the frame? Yes. Okay, so you have another one here, which is from the triangle. So half times 200 Newton per meter times 3. So becomes 300 Newton, right? Okay, and then you have the distance. So this one is halfway, so the whole thing is 8 meters, so this is 4 meter. And then 5 plus 2, which is 7 meter, and then the whole thing is 8 meter, right? So that is the free body diagram. Next, after establishing the free body diagram, you will solve using equation of equilibrium. So as usual, the easiest way to start is taking moment, summation of moment. About point A here is 0 if you take counterclockwise positive. So again, this NB is counterclockwise, so you have NB times a distance of 8, and then this is clockwise, so minus 1600 distance of 4 minus 300 distance of 7. It should be equal to 0, right? From here, NB can be calculated to be 1062.5 Newton, right? Then you have summation of Fx equal to 0 if take right to the right as positive, so again you have Ax equal to 0. So there's no horizontal forces in this question, so this is quite a bonus question, I guess. Summation of Fy equal to 0, so we'll have Ay minus 1600 minus 300 plus 1062.5 equal to 0. So you can calculate for Ay equal to 837.5 837.5 Newton. All right, so yeah, straightforward again. When you have diagram like this where all the forces is vertical except for one, where this one will be 0, of course, then the calculation will be quite straightforward as such, right? So if you have this kind of question in your final exam, you should do sujud syukur because it's so easy, right? That's why it's rarely come in the exam. Anyway, yes, part B. If the support at B is replaced by a pin support, right? So at B here, originally, if you take a look back at the diagram, it is a roller, right? Hence, you have reaction like this. So do you know the answer? If the roller is actually replaced by a pin support, right? So what will happen? And the question here is actually quite straightforward. Can the reaction at A and B be determined? Can you determine all of this reaction and why? Right, so the answer is quite straightforward if you understand the concept already. When you have pin support here as well, rather than a roller like this, then it means that you will have X and Y support reaction there, right? So what will happen? As a whole, you have 4 unknown, right? 1, 2, 3, and 4. And with 4 unknown, and you only have 3 equations, 1, 2, 3, it means that you cannot solve. So it's basically statically indeterminate, right? So you can use that word straight away, statically indeterminate, or just say you cannot solve because you have, and that's why there, right? So you cannot solve because you cannot determine the support reaction because the number of unknown is more than the number of equation. All right. So moving on to the next question. Okay, in this third question for today, you will have the diagram on the left here, and then the question, right? So you'll have the question A, B, and C there. It states that the steel plate, so you know that the diagram there, it is a steel plate, is 0.4 meter thick. So you know the thickness, meaning the true thickness is 0.4 meter, right? In the Z direction, of course, and has a density of 7800 kilogram per meter cube, right? So the density is given, the thickness is given. Determine the coordinate of the location of its center of mass. Clearly state which element is being used if integration is used for calculation, right? So the question actually hinted already that you have to use integration to solve that one. And then part B, draw the free body diagram of the steel plate, and then part C, compute the reaction at support A and B, right? So if you understand this question, the part that is related to our chapter or subchapter today is part B and C. Draw the free body diagram, which we actually have in the previous tutorial, and then compute the support reaction, which we are covering today. However, it has to start with something in part A, where it states that you have to determine the location of the center of mass, right? And then, of course, another thing that the question did not explicitly say it, but you have to actually determine as well is what is the weight of the plate as a whole, because when you draw the free body diagram, you have to know the weight, right? And then you want to calculate, you have to know the weight as well. Hence why it gives you the density, right? So this question is to illustrate to you that even though you have understood chapter 5, but if you do not know chapter 9 yet, you are stuck with this question, right? So in terms of the approach for today, for today's tutorial, I think this is what I'm going to do, right? I will actually solve this question in total, meaning that I have to use what I know from chapter 9, and then I will solve until the end, right? So the one that is related directly for today's tutorial that you have to understand today is part B and C, how to draw the free body diagram, and how to calculate for the support reaction using the equation of equilibrium, right? However, we cannot go to that point until we have solved part A first, right? So what I will be doing, I will be solving in total, including part A. So it's up to you whether either you want to skip the initial portion, just skip, just fast forward or something, and just straight away watch after part A is completed, and then you see how the free body diagram is drawn, and then the equilibrium problem is solved and the support reaction is being determined. That's one approach. Second, you can just watch through the whole calculation, even though you haven't learned it yet, even if you do not understand fully, just to appreciate the reality of the question for the final exam, and to give you the appreciation that if you do not understand every chapter, sometimes it can haunt you in the exam, right? So for example, in this question right here, right, if you understand chapter 5 but do not understand chapter 9, you are in trouble, right? Right, so it's up to you what you want to do. You want to skip that portion, the beginning portion, or you want to just follow and listen through and just see what happened. It's up to you, right? So I'll move, I'll begin calculation, inshallah. Alright, so basically what we want is, just to give you the idea first, right? So we want to draw the free body diagram, and the pin support here and the normal reaction here from the roller is quite straightforward. You should already know, you should have already understand that. But you have to have the weight there as well, and this one have to have a position, so that when you want to calculate moment, etc., you know the distances, etc., right? So that is where we have to solve first for part A, right? So as I mentioned, I will just go and calculate. It's up to you whether you want to go through or you want to skip to the part that you are interested in. Alright, so there's two things that you have to determine. One is the location. So part A here is specifically say what is the coordinate, right? So that is the position. So here this is the understanding of chapter 9. So you have to determine what you want to do. So I will take vertical element here. So I bring it out. So this is vertical element. So basically we will have this is dx. Let's say this is what? This is curve 1, this is curve 2. Hence this one is x1, y1, x2, y2. So meaning this one is y2 minus y1. Hence dA is y2 minus y1 dx, right? And for the centroid here of x with y with there, so x with is x, y with is y2 plus y1 over 2. Alright, so going to the integration. So we have the equation x bar equal to integration of x with dA over integration of dA, y bar equal to integration of y with dA over integration of dA. Alright, solving for x bar first. X bar equal to integration x with is this one, so x, dA is, okay, y2 is what? So this is y. So from here y is square root of 2x, right? So 2 power of half x power of half, and then y here is minus x, right? So in this case y2 minus dA is, where is dA? y2 minus 1 dx. So y2 is this one, so 2 power of half x power of half, then minus y, minus this one, minus become plus x dx over integration of dA. So 2 half x half plus x dx. The integration is from here to here, which is from 0 to 2, 0 to 2, 0 to 2. Alright, so this one we have to expand first, 0 to 2, so this one become 2 power of half x power of 3 over 2 plus x square dx over integration 0 to 2 power of half x half plus x dx, and then integrate. Okay, so 2 power of half, this one becomes x power of 5 over 2, so 2 over 5 here, plus x cube over 3, so it is from 0 to 2, and then here 2 power of half x, oops, so x power of 3 over 2, so we have 2 over 3 here, where is it, this one, right? Plus x square over 2 from 0 to 2. So you plug in the number here. So if I cut short that, plug in the number, you will get 44 over 35. 44 over 35. Right. So if okay, I'll show you the step before I divide that. So it's basically 88 over 15. 88 over 15 divide by 14 over 3. 14 over 3. Hence you'll get 44 over 35, or this is equivalent to 1.257 meter. Of course, if you have covered this chapter, there's a reason why I prefer to keep this number until the end before dividing, because it's easier to use this one for another calculation afterwards. Alright, so basically x bar you get 1.257 meter, right? So that's the coordinate you want to find there, right? So I will write somewhere because I have to erase this one. So x bar is, you get x bar is 1.257 meter. Alright, calculating for y bar. Do you have enough space? Because it's longer, I think. So y bar, integration of this thing, so integration of y bar is this one. So if I take half outside, so you get y2 plus y1, and then dA is y2 minus y1 dx over integration of y2 minus y1 dx. This one, if you simplify this first, so half, and then integration of y2 square minus y1 square dx over integration of y2 minus y1 dx. Oh, sorry, this is not y square, this is y. Oh, y2. And then so this is plug in all these things, so half integration of y2 square is 2x minus this square, x square, so x square dx over integration of what do we have here before, 2 power of half x power of half plus x, right, dx. If you integrate this one, you get half, integrate this, become 2x square over 2 minus x cube over 3 from 0 to 2, and then here is basically the same as before, right? 2 power of half x power of 3 over 2, 2 over 3 here, what is it, plus x square over 2 from 0 to 2. If you replace this and you plug in to make things short, so if you plug in all of this, you will get basically what, 2/3 divided by 14/3 and then you get 1/7 or 0.143 meter. Right. So from that calculation, basically you get y bar is 0.143 meter. Right. So that actually answer the first part A, right? So what is the coordinate? So the coordinate will be x bar, y bar coordinate will be 1.257, 0.143 bracket meter, right? So that's the coordinate. Basically, if I write it, x bar, y bar is 1.257, 0.143 meter. That's the location, right? However, to draw the free body diagram, we have known the coordinate of the center of gravity or center of mass, but the value of the weight itself is not yet determined, right? So how to get the weight is basically the area under the graph, right? Basically, that's representing the load, right? So that's why we will calculate, because I prefer this to be maintained until the end, right? This thing, if you okay, it's not a problem if you do not understand this yet if you're watching it now, right? But just for example, after you have covered everything, you refer back here, then it will be useful. I'll just explain certain things, right? So we want to maintain this because if you notice before, x bar you also have the denominator 14/3, and that is this one here, right? And that is the area, right? So that is what you want to calculate the weight. So it is 14/3, right? So the area is 14/3, right? So to calculate the weight, okay, so I'll remain that one there. To calculate the weight is basically, you know, the if you want to have the weight is basically the area is 14/3 meter square, right? But also the question already give you the thickness, so it is 0.4 meter, right? So 0.4 meter thick. So from here you get meter cube, which is the volume. As well, you have the density. So 7800 kilogram per meter cube, right? So you multiply this, all of this, you'll get into kilogram. Okay, so let's do one by one. So this is mass first, right? So you'll get a value in terms of kilogram. Had I calculate that one? 14,560 kilogram. So the weight is basically this value, 14,560 times 9.81. You basically get 142,833.6 Newton, yeah, or 142.8 kilonewton, right? So basically now you have the weight and you have the coordinate. Right now we will continue for chapter 5. We can now establish and draw the free body diagram with this weight and the coordinate known, and then we proceed with the solving of equation of equilibrium, right? So I should take note of this, but yeah, I have to do that. Okay, so after having done with the chapter 9 portion, we will come back to this free body diagram here, right? Okay, so let's stay true to the shape for a little bit. So something like that. You have AX and AY, and then you have normal there, which is perpendicular, right? This is perpendicular, or in other words, because this thing here is, this one is 45 degrees, so basically this one is 45 degrees, right? So what else? Yeah, what we have just calculated just now is the point here, right? So where this distance is, what was it right now? So this is 1.257 meter, and then the vertical distance is 0.143 meter, right? So that's the location, and then the force itself is the weight just now we have calculated, so it is 142.8 kilonewton. This is if you want to express it in kilonewton, right? So 142.8 kilonewton. Now we have the free body diagram. Of course, what else is needed? So depend on what you will need to use afterwards, right? So basically, but the distance, for example, this distance is 2 meter, and the rest, right? So we need to find AX, AY, and normal reaction there, right? So easiest way, as usual, as the previous question as well, so we start with the moment, right? So summation of moment, and start with A is easier, so summation of moment about A is 0 if I take counterclockwise as positive. Now so you'll have this normal force and then this weight, right? There's no other forces here. So there's two ways actually to use this one, to calculate this one, right? One is to resolve into x and y and then just use the perpendicular distance. Second, if you understand, this NB is actually perpendicular to this distance, right? So if you know this distance over here, then you can just this multiply by this distance, because it's moment equal to force time distance. That distance d is the perpendicular distance. So I'm going to show, I'll show both, right? So if I'm taking this multiplied by this perpendicular distance, I need this perpendicular distance, right? So it's easy to calculate, because this is 2, this is 2, this will be just square root of 2 square plus 2 square, and it will be 2 point, what is this, 2.8284 2.8284 meter, is it? 2.8284, right? So if you calculate that one, verify, it's basically 2 square root of 2, right? I don't have my calculator here, but yeah, so you can calculate that one. So based on that, if I'm using the red one, so NB will be NB, because it will be clockwise, counterclockwise, so it's positive, times 2.8284, and then this one will be clockwise, so minus 142.8 kilonewton times distance of 1.257. This should be equal to 0, and from here NB you can calculate to be equal to 63.5 kilonewton basically, right? So that's one of the answer, because you are solving for AX, AY, and B. So this is one of the answer. That is if you use this one, this distance here. For those who do not understand what is going on, you also can resolve to X and Y. Normally it's suggested like that, right? So because normally that is easier to get the perpendicular distance, vertical and horizontal, right? So if you resolve into X and Y, your calculation will be like this. So for the horizontal, it will be NB cos 45 degrees, which is this one over here, and then the distance will be this distance, right, times 2, and then the vertical, that's counterclockwise, right, and then the vertical is counterclockwise as well, so plus NB sine 45 degrees times distance of 2, which is this 2 here, right, and then minus 142.8 times 1.257 equal to 0. If you calculate this one, NB should get the same answer, 63.5 kilonewton. So either way, it should give you the same answer. Do verify if you do not trust me. Do not blindly trust anyone, just prove it yourself, right? And then you will be convinced, inshallah, right? So that's the nature of the world, right? So either way, you're calculating the same thing actually, it's just the different method, different way of resolving, etc. The answer should be the same. All right. Okay, so after that, it's just summation of fx and summation of fy to get the remaining force. So after that, you can do the summation of fx equal to 0. And here you will not have 0 as the previous two questions because you have other force to have x component, right? For example here. So you'll have ax. This one doesn't have any x component. This one, based on this answer, it will be plus 63.5 cos 45 equal to 0, right? So you will actually get ax equal to negative. You'll be negative 44.9 kilonewton. What does that mean? This negative mean what? Meaning that the assumption is not correct. Meaning that this the actual one is not to the right but to the left. So meaning you just indicate it is actually to the left, right? No problem. Right? If you assume to the left from the beginning, this will be negative, right? So and you will get positive answer, meaning that it's actually to the left, correct? Do not when you have established your free body diagram, do not change, right? When you get negative here, just say it is to the left, right? Do not change and then you change and then you don't change here, and because when the examiner examine it, they will just follow through the process, right? So if this doesn't match this one, it will be a problem to you, right? Again, another equation, summation of f y equal to 0. If I take upwards as positive, then you have ay, then minus 142.8, this one, and then this one plus, what is it, 63.5 sine 45 degrees equal to 0. So from here you can calculate ay. Oops. And then you'll get 97.9. So meaning that the assumption direction is correct, it is upwards. So there you go, you'll have the normal reaction here, ax and ay. So that's how you solve the problem. And as you can see, it's not difficult actually, right? So it's just the same routine. Draw the free body diagram, summation of moment, summation of fx, summation of fy. However, summation of fx and fy is standard, right? It's just x and y. But summation of moment, you have to select which point, because it's basically, this is basically moment about a point calculation and it's equal to 0, right? So you can actually select any point you want, but not any selection will give you the same level of difficulty of easiness or easiness to solve, right? So always select a point where you have multiple force. For example, 1, 2 force, select here. Hence, this two doesn't have any moment. You can straight away calculate. That's the routine that we normally have. After you have done several exercises, you know already that's what you should do. Yeah. All right. So that's all for today. That's the only 3 questions that I can find in the recent years of exam in our institution in UIA for 2D, right? In the next tutorial, we will have a lot of questions in 3D, right? So even though this tutorial here is shorter than normal, I think, what's the time now? I think it's shorter than normal, right? But the next tutorial will be longer than normal because the question is a lot and each question is much longer. But everything starts with the initial understanding of 2D, right? So make sure you understand how to resolve in 2D from the understanding the support reaction, drawing the free body diagram, and solving equation of equilibrium, right? So in this case today, all of our question is quite easy because there's no simultaneous equation. It's straightforward, right? One equation, one answer, one equation, one answer, one equation, one answer, right? But it is possible to have simultaneous equation. It is possible. If you want to test yourself, please find in your textbook some questions that will test you in that simultaneous equation, right? So at least you are tested, and you train your mind to actually addressing that question, right? Other than that, I think that's all for today. Hopefully you also understand the question number 3 just now that we have covered, that it is merging between several chapters, the understanding from several chapters, to be able to solve the question, right? So do not worry, for the integration part we will cover in chapter 9, but at least you are aware that, okay, I have to actually understand all the chapters to be able to solve any particular question, because it can actually combine various elements in one question, right? Okay, thank you, inshallah. Hopefully this has been beneficial and you have learned something from this video. If you did, if it is beneficial and if you get value from this, feel free to like the video. It will help in terms of the YouTube algorithm. Thank you. Wabillahi taufiq wal hidayah. We see you in the next tutorial, inshallah. Wassalamualaikum warahmatullahi wabarakatuh.